A sample of an ideal gas goes through the process shown in figure. A, B, B, C, C, D, D, A. We have a clockwise cycle. In this case, we must have a delta omega cycle must be positive, and the dq of the cycle must be positive. Okay, from A to B, it's adiabatic. Adiabatic, okay, from A to B, we are adiabatic. What I mean by adiabatic? Adiabatic, delta Q AB equals to O, okay? From B to C, anyway, you know, from A to B, we have a decreasing of volume. The volume decreases, so omega AB must be negative, and delta omega AB must be negative. Okay, B, C is isobaric, so P is constant. We have B, C is isobaric. We have P constant, or delta P, BC equals to O, and with 100 kilojoule of energy entering the system by heat. So delta Q gained by the system, it means it's a positive value. We have delta Q B C equals to plus 100 kilojoule. It must be positive. Okay. Here we increase the volume, so d omega B C must be positive. The omega by the gas, From C to D, we have an isothermal. T is constant. So we take C, D, we have delta T equals to O, isothermal. We increase the volume, so the omega CD must be positive, okay? From D to A, DA, we have P constant, isobaric, and we decrease the volume, so the omega of DA must be negative. And we have 150 kilojoule of energy leaving. Leaving, it means lost by the system, it must be negative. So delta Q dA equals to minus 150 kilojoules. You have to know alone that when we lost the heat, it must be negative. When we gain the heat, you have to write it plus. Okay, first of all, I want to find delta E AB, delta E BC, delta E CD, and delta E DA. Okay, let's start with delta E AB. Here, just I want to write, first of all, DC, okay? I want to find delta E B C second delta E BC DC, and finally we can say delta E DA and AB. Okay, like this you can solve the problem. So first of all, I want to find BC. That's all. Okay, to write BC, you know, we have delta E BC equals to delta Q BC minus delta omega BC. BC, we have P constant, okay? And I have the value of dq. I have to find the omega. So we have to find d omega BC, which is equal to P to the integral P dV between B and C. P is constant, P, V final equal VC minus VB. If you come here to P, B, and PC equals to 380 M, so 3 times 10⁵ Pascal, okay? V of C equals to 0.4 minus VC VB equals to 0.09. Okay, M cube. We get here the omega between BC must be positive because we increase the volume. The answer will be kilojoule, 94.2 kilojoule positive, increasing the volume. This is the energy done by the gas. So to calculate delta E BC equals to delta Q plus minus delta omega. Delta Q equals to 100 kilojoule and delta omega, here we have a positive. Okay, so we have 94.2 kilojoule. We get here 5.8 kilojoule is a positive value. So this is, first of all, delta E BC. We can put here, in the case of BC, we can add delta E equals to 5.8 kilojoule, and delta omega equals to 94.2 kilojoule. Okay. Second, delta E DC. In the case of CD, we have to write, first of all, we have BC, CD. Delta E, CD, you know, delta E for any case equals to N CV delta T. In the case of CD, we have an isothermal process. So delta T equals to O. So delta E equals to O. Okay? So we can add it after delta E dA, delta E dA equals to delta Q dA minus d omega dA. I give you delta Q. We have the value of delta Q. You can find the value of d omega. dA, we have P constant. So d omega dA equals to P dV from D to A equals to P V final minus V initial. Don't forget, here we have P constant, okay? P constant. Between dA equals to 1. 1 times 10, 5 Pascal. VA equals to 0.2. VB, VD equals to 1.2. You know, from D to A, we decrease the volume, omega must be negative. So d omega equals to 101 kilojoule, must be negative. Okay, we have the omega. We can calculate delta E dA equals to delta Q dA is given equals to minus 150 kilojoule, okay, minus, and d omega equals to minus 101 kilojoule. We get in total, it will be 48.7 kilojoule negative. So delta E is negative. This is delta E dA. Delta E dA equals to minus 48.7 kilojoule. And we calculated delta E dA, delta omega dA equals to minus 101 kilojoule. Okay, you have to write all the results like this. This is about dA. The last one, we have to calculate delta EAB. Delta EAB. You know, here we can go directly to the cycle. In the case of cycle, delta E of the cycle equals to the summation of delta E AB plus delta E BC plus delta E CD plus delta E dA equals to O of the cycle. So to calculate delta E AB, delta E AB equals to minus delta E BC minus delta E CD minus delta E dA. Okay, you do the calculation. You know delta E B C equals to 5.8 minus 5.8 kilojoule. Delta E CD equals to 0. Delta E dA equals to minus 48 48.7 kilojoule. Finally, we get delta EAB equals to 42.9 kilojoule. Okay, it's important to know every point. Try to solve it without solution. It's important to try to find any expression for any process and you understand the physical meaning of each one. In the case of a positive value, negative value, P constant, V constant, T constant, Q equal to 0. For each case, you have to know the expressions of delta Q, delta E, and delta T.